All right, in this video, we are going to continue talking about file input and output in Java, specifically the java.io package. And um, we are going to talk about character streams this time. So, in the previous video, we talked about byte streams, right? Those are streams that are designed to read from and write to binary files. But character streams are streams that are intended to read from and write to text files. All right, so that's just a basic .txt file if you're on Windows, or and just it has some character encoding that translates it to a sequence of characters. So, all right, and so the reader class is an abstract class that is the parent class of a lot of the input. This should say character streams, right? There's a typo right there that needs to be fixed. So just get rid of byte here. So input character stream classes in the java.io package. And then the writer class is an abstract class that is the parent class of many of the output character streams in the java.io package. All right, so that's similar to input stream and output stream from the previous section. All right, let's take a look at some of the reader child classes. So buffered reader, filtered reader, piped reader, input stream reader, string reader, URL reader, and char array reader are all child classes of the abstract reader class. Okay. In particular, we are going to look at file reader, which is actually a child of input stream reader, and buffered reader. Okay, so file reader is pretty basic. And then buffered reader is, the preferred one, and it's a lot easier to use. But we'll talk about file reader first, okay? And obviously, buffered reader, as the name implies, is a buffered stream, right? Meaning that the characters are read to memory, where like kind of a waiting area for the characters that are read in. So therefore, more efficient than file reader. All right, and then writer. You can see all of the similar writer classes that are child classes of the writer abstract writer class. In particular, we are going to talk about buffered writer and file writer, the counterparts of file reader and buffered reader. Okay. All right, and as you probably have noticed, the naming conventions that file writer is going to be sort of the more basic version of, and then buffered writer is going to kind of be wrapped around the file writer and offers a little bit more functionality, as well as the fact that it's buffered. It's going to make it more efficient than file writer. All right. All right. Let's take a look at each of these two classes. First, with file reader and file writer. So let's take a look at file reader. So for file reader, this is just how to make a basic file reader, how to read a file using a text file using file reader. All right, and so it's this text file that we're reading. So alpha.txt, you can see there's some Latin text in there, and so in order to do this, I'm going to use, again, a try with resources and just create a file reader object. And then I am going to use the read method out of the file reader to read in a character. All right. So it's going to read that character as an int. Okay. If the reader is at the end of the file, the int that it reads in will be a -1. Okay. So that's similar to the situation that we were talking about with some of the byte streams. And so while that character that we read in is not equal to -1, then what we're going to do is print out the character and then read in another one. So the character gets read in as an int. All right, and then so what you're going to have to do is typecast it to type char to get it to print as a character. All right, and so this loop will just read through every single character and print it out. Then we have a catch for IO exception. That's the exception that's going to get thrown if in the process of reading there's some issue. It's going to throw that exception. And here I didn't do anything else but just print this message. And then again, with try with resources, we do not have to close this file reader. So when we run this, we should get all of the text that's printed out. To see what happens when you forget to typecast this to char, you'll just see a bunch of numbers when you do that. All right, so that's what it looks like when you forget to change it, right, or to typecast the integer as a char. So again, that's what you're going to have to do. Next character returns an int. So make a manual type conversion or typecast to the char data type, and so that will cause it to display like the text file in there. Okay. Okay, and so that's it for this one. Let's take a look at the file writer example. It's very similar to what we've done before. So here I'm going to use file writer, the file writer class, to create a text file. So I create a new file writer object inside a try with resources, okay, and it's going to write to the file writer.txt. And I'm just going to use the write method, and that write method is going to write these lines to the file. All right. The thing about write is it will overwrite the existing file, okay, whereas append will add to the end of the existing file. All right, so let's run this. Here I'm going to refresh this so you can see there's no file named filewriter.txt. So I'm going to compile this and run it. All right, and then you can see it generates this file, filewriter.txt. Okay, so it wrote these 3 lines to the file and then appended this last line here. So let's run it again. And if you get this message, it just means that JGrasp has detected that filewriter.txt has changed. So it's going to ask you, hey, do you want to reload? I'm just going to click always reload, right? So I don't have to go through this again. All right, so that's what it looks like. All right, if I change it slightly and just change these numbers, I'll change this to 4, 5, and 6. I guess I'll change this to 7. And run it again, and then look at filewriter.txt. You can see, right, that it overwrote those first 3 lines. Okay, so here it overrode 7, 5, and 6. Right, so those lines that we had in there before, line 1, line 2, line 3, were overwritten in there. So, so again, if you just want to overwrite the lines that are already in the file, then use write. If you don't want that to happen, do append. So if I do append again, if I change these to append, and change these back to 1, 2, and 3, you'll see that all of the stuff that was in the file right now is still going to be there. And all of the new stuff will be, well, I was supposed to do that, but it did not do that. All right, so I have to figure out, well, that what's the story with that? Because it should have added that on there. So not totally sure. Let's run it again. So there's some issue with that. I'll have to figure out what the story is with that. Okay, because it seems like it's overriding anyway. And there may be some thing we can do to prevent that when we open it up. All right, but for right now, let's just kind of continue and look at buffered reader and buffered writer, which, in my opinion, are the ones you should be using anyway with this. So let's take a look at those. All right, first at the buffered reader example. The buffered reader works pretty much like the file reader example does. You would create a file reader object and then wrap it in a buffered reader object inside the try with resources block. One of the nice things about buffered reader is that it has this read line method. You can read entire lines at a time, and you can read them in as strings. Okay, so when you can see, I can read alpha.txt. I can just read it line by line and process it that way as well. Okay. If you are at the end of the file when you're using read line, then the line will be read in as null. So in the while loop that you're going to need to use to read the all of the lines in the file, right, then the condition is going to be while the line is not equal to null, whatever your variable you're using for the line that you read in. All right, you can see there's no typecast. It's read in as a string, so you can just print it out. And not to mention, so these methods are just more convenient and than the file reader, and it's buffered as well. So so this one is a lot nicer than file reader. Although you do need to create a file reader object, right, in order to do this. All right, and next up, the buffered writer. All right, that writes this file, buffered writer output file.txt. So that's right here. You can see these are the lines of text that we get. And let's see what happened. If we get that same behavior, then we're going to have to look it up. Just like with file or buffered reader, you're going to have to create a file writer object first and then wrap that in a buffered writer. All right, we're going to change all of these to append, and we're going to see if it actually does the appending this time. So all right, so it's not doing it. So let's take a look at buffered writer class. So Java 11 API and then buffered. Writer. Okay, it's because this there is no append class in there is no append method in buffered writer, so it's using the old one, so that's not working as well. So I guess we'll have to go back and figure out why it's not working in file writer. Okay, so yeah, in file writer it does. So you do have to use the Boolean append on here if you're gonna do that. So, all right. So let's see. Let's look at this method. Append char. Append the character sequence. All right, let's just try it with. All right, so this is what buffered writer output looks like here. If we want to append, then if we go here to buffered writer and we do true, add a true in there and then compile it. Let's see if that actually gets us to append. Alright, so that's what that looks like right now. And then if this is successful, then it should have these same 3 lines echoed after it. If not, then it should only have 3 lines. All right, so there you go. That the append worked. So what it looks like is that in order to append, when you create your file reader object, right, you're going to have to put this extra true in there. And now let's see if I put write, change this back to write. Will it completely overwrite the file? Alright, so that's what it looks like now. If I do this with a write, even though I have true up here, this true parameter in the constructor to the file writer, the question is when I run this and just have write, will it overwrite this file? So if that's true, if it overwrites it, there should only be 3 lines now in here, but there's not. Okay. All right. So whenever you create, so it looks like, right, whenever you create your file writer, right, if you want it in append mode, then you're going to have to put this true on here and remove it if you want it to just write over the top. So now when I compile this and run it, then I'm going to get only 3 lines. Okay. All right. So that looks like how it's going to have to happen here. All right. Okay, so that is it. Most of the time I don't, if I'm generating text files like this, then I'm usually overriding, not reading, not appending to it. So, but there are some times when you want to append. So, okay, so I think that is just about it for this. There is this section here on file organization, right? A field holds a single factor attribute of an entity. So, and then a record is a collection of related fields. A file is a collection of related records, right? And files are integrated into a database. And so that's sort of where we're headed here. So let's take a look at an example of this, and let me get the file in the right place here. So just to illustrate this, concept, what I have is a comma separated value file, fake student data. All this is fake, right? It's just these names are just generated at random. So so inside this student data here, what I've got is for instance, right here you can see the first value on each line is somebody's name. So that would be an example of a field. It's a single fact or attribute of an entity, right? So here I have, I think that's the student ID, right? So that would be a field. Here I think is GPA, so that would be a field. And then the fourth value in here is the email, okay? So that would also be a field. So this file, right, has a name field, an ID field, a GPA field, and an email field. So those are examples of fields. A single fact or attribute of an entity, right? So a record is a collection of related fields, and so that would basically correspond to a row. Okay, So this is a record, this would be another record here, this would be another record here, right? And so on and so forth. So the records, you can kind of think about them as being rows, right? The fields, you can kind of think about those as being columns in your file, all right? And the records are related, right? All of this information is for this fake student, Jolie Vanstone, right? All of these fields are related because they are the information related to Corilla Murfin, okay? And then a file is a collection of related records, right? So all of these might be students in a class, right, or in a college. I think there's a lot, so it'd probably be a college, right? I think I generated 1,000 of these, which is the max that you can generate for free on the online service that generated these fake student data. Okay. That's used a lot of times for testing, right? You want some data to test, but you don't want to expose your client's data, so you can generate some fake data to do some testing. All right, so this is an example of a file, and now there might be many files, right, related to students. Maybe this one was about just basic information, but maybe you have some files related to payment records and things like that, or academic records and things like that. So you could have a bunch of files together. Those would be integrated into a database, okay? And honestly, the database is kind of where we're headed. And most apps that you're going to make these days in production, they're not going to keep the data in a file like we're going to do in these examples, but it is important to understand how that works, just kind of as a building block into the database, right? Over time, people discovered, hey, that keeping a bunch of records in a file on your computer is not a great way to store data. Over time, what ends up happening is that the errors like slowly creep into those files, and that's going to cause an issue. Eventually, the data will get kind of so corrupted if you don't take really good care of it that the data you have is kind of useless. It really has to be maintained in a decent manner, and so that's what most modern database management systems do. And people realized over time, okay, that's how we need to be keeping track of the data, because especially if you have large amounts of data, it has to be really organized, and you also have to prevent like those errors from creeping into the data. That is a whole class in and of itself, and probably multiple classes. But if you take a database management system class, those are the kinds of issues that you'll be talking about. How do we maintain our database in a way that prevents the data from becoming corrupted over time? Okay. All right. So I just wanted to mention that. One of the other things too, before we get into these examples, we've been talking about the EO package. There is the java.neo package, and that uses a totally different concept called channels instead of streams and buffers. These channels are bidirectional, right? Meaning data, they can be used for both input and output. So streams are unidirectional. That's why you have one for reading and one for writing. The channels can kind of go both ways. And the other very important thing about channels is they support unblocking input and output, whereas streams don't do that. Okay, with a stream, right? If it's still going, then that's going to block any other input or output that goes, and until that's finished, then you're not going to be able to do anything else. Well, when you deal with networking applications, when you're writing programs, you can't have that. Okay, you can't have a server like that's busy, for a business or something like that, like Amazon.com, right? Where if one person's ordering some stuff and that it blocks everything else, and you can imagine that's not going to work very well, right? So you have to be able to kind of communicate back and forth, and that's what the java.neo package is. There's a lot of new things though that are involved with learning the java.neo package, which is why we're talking about the older version. So because it's a little bit simpler to learn. There's less stuff that you have to learn about the Java.neo package. A lot of the things that you learn here are going to help as well. All right, so in the next video, what we're going to do is work through this example, and then we'll have another example of writing streams that deal with text files after that.